Hello, hi everyone. Welcome to the Student the Brand. This is Eva Seva sir. Today we are going to discuss about light reflection and refraction. Light reflection, and refraction. So hi everyone. Welcome to the Student the Brand. Today I am going to discuss about light reflection and diffraction. Okay. So what is the reflection? Reflection is nothing but the bouncing back of the light from the reflecting surface. So I am considering this one. So this is a reflecting surface. This is a reflecting surface. When the light is incidenting on the surface, so this is the incident ray I am considering, and this will be the reflected ray. So the light which is incident on the surface, that is incident ray. The light which is reflecting back, that is called reflected ray. The line which is perpendicular to the plane surface, that is nothing but perpendicular, that is called normal line. So this is the normal. So this is incident ray, reflected ray. So here I am considering incident ray. This is incident ray I am taking. Incident ray. And this will be the reflected ray, and this will be considered as a normal line. So here I am considering the deviated line. So actually this undeviated line. So our initial direction of the incident ray, so incident ray, reflected ray, normal line. So this is the initial direction of the incident ray. So the angle between incident ray and normal line. Is called angle of incidence. So this is called angle of incidence. And angle between reflected and normal line is called angle of reflection. Angle between incident ray and normal line. So this is the incident ray and this is the normal line. The angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. And the angle between reflected and deviated line is called angle of. So this is the initial direction of the incident ray or undeviated line. So that is the angle of deviation. Okay. So now we can see the bouncing back of the light. Or reflecting back of the light from the reflecting surface is called reflection of light. The bouncing back of the light or reflecting back of the light from the reflecting surface is called reflection of light. Okay. So that is called reflection of light I am considering. And now here we can take, there are two laws of reflections are there. Laws of reflection. There are two laws are there. So what are those? First one is angle of incident equal to angle of reflection. First one I am considering angle of incident equal to angle of reflection. So angle of incident equal to angle of reflection. Second one is, so incident ray, reflected ray, normal line lies on the same plane. Incident ray, so reflected ray, normal line. So incident ray, reflected ray, normal line lies on the same plane. So angle of incident equal to angle of reflection. Angle of incident equal to angle of reflection. Incident ray, reflected ray, normal line lies on the same plane. So these are the points. Okay. So these are the laws of reflection. So it comes under laws of reflection, right? Yes. So now we can consider this linear angle. So this is the linear angle. I am taking the linear angle. Okay. So this is the linear angle. How much? 180 degrees. This linear angle is 180 degrees. So that is the part of angle of incident plus angle of reflection and angle of deviation. This everything will be mixed. So angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. From loss of reflection, so we can consider angle of incidence plus angle of deviation equal to 180 degrees. So we can consider 2 angle of incidence plus angle of deviation equal to 180 degrees. And also we can take angle of reflection also we can consider. So here 2 angle of reflection and angle of deviation equal to 180 degrees. Like this also we can write, we can consider. So this is about reflection of light, the bouncing back of the light from the reflecting surface. Okay, so this is incident ray, the light which is inciding on the surface, incident ray. The light is reflecting back is called reflected ray. So the line which is perpendicular to the plane surface, that is called normal line. Incident ray, reflected ray, normal line. So loss of reflection, angle of incident equal to angle of reflection. And here we are considering, so this undeviated line or initial direction of the incident ray, So angle between incident and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. So this is about angle of incident, angle of reflection and angle of deviation. This is about loss of reflection. So as I said, so linear angle 180 degrees I am considering. So angle of incident plus angle of reflection plus angle of deviation equal to 180 degrees. So angle of reflection is nothing but angle of incident. So I am taking like this from loss of reflection. If you add this one, angle of incident plus angle of incidence plus angle of deviation equal to 180 degrees. 2 angle of incident plus angle of deviation equal to 180 degrees. So this is about okay, so reflection of light, complete reflection of light. And here there are 2 types of reflections, regular reflections and irregular reflection is there. Irregular reflection or diffused reflection. So we'll discuss about that. Regular reflection means, so if you are taking the plane surface, I am taking the plane surface like this. Okay, so incident beam is parallel. So this incident beam. So I am considering this incident beam. So this incident ray, one line incident ray, and this one also, one more, and this one. So all whatever light rays are incidenting, all are parallel to each other. So this is called incident beam. So reflected beam also parallel to each other. So like this I am considering reflected beam. So reflected beam also parallel. So this type of reflection is called regular reflection. This type of reflection is called regular reflection. Okay. So whereas irregular reflection, regular reflection takes place on smooth surface. Regular reflection takes place on smooth surface. Okay. So it takes place on smooth surface. Whereas irregular surface, I am taking. So irregular surface I am taking like this. So here I am considering. So incident beam. So this incident beam, one light ray, another light ray. So like this I am taking. So incident beam is parallel, but reflected beam is not parallel. Reflected light rays are not parallel. So this type of reflection is called irregular reflection or diffused reflection. Irregular reflection or diffused reflection. So when incident beam is parallel, so this incident light rays are parallel. Okay, reflected light rays are not parallel to each other, so it moves in different directions. So this type of reflection is called irregular reflection. Irregular reflection. So this is a regular reflection. Regular reflection means incident beam is parallel, but incident beam is parallel and reflected beam also parallel. This type of reflection is called regular reflection. Irregular reflection means incident beam is parallel, but reflected light rays are not parallel to each other. Okay. So next one. So we'll go through that next one. So object and image I'll explain. Object and image, object and image. So real object, virtual object, real image and virtual image. So I'll talk about object and image. So here I'm considering. So if you take the plane mirror like this, so I'm taking the plane mirror, okay. So principal axis I'm taking. So here I'm taking the real object. This is a real object. Real object. Real object means, so the incident rays are coming from that point. The incident rays are coming from that point. So these are the incident rays. One light ray I'm taking, another light ray I'm considering. How many light rays are required to form the image of the object? Minimum 2 light rays are required. How many light rays? Minimum 2 light rays are required. So after reflection, so like this, and here also I'm considering. If you extend those light rays, if we are extending those light rays, okay. So here virtual image will form. Okay. So we are extending the reflector light rays. Here the point of intersection of incident rays, the point of intersection of incident rays, so is called real object. The point of intersection of incident rays is called real object. The point of intersection of extended reflector light rays. So this is a reflector light ray, this is reflector light ray. So we are extending those light rays. Those light rays are meeting at one point on the principal axis. That is called virtual image. Virtual image. Okay. So this is a virtual image. So this is a real object. Here, if the object is real, image is virtual. If the object is real, image is virtual. I am taking, so one more case. I am taking different case here. You can see. So light rays are coming from certain point or infinity. I am taking light rays are coming from certain point or infinity like this. So we are extending this light rays. So we are extending this incident rays. So these are the incident ray IR1. So this is IR2, and this is the reflected ray RR1, reflected ray 2. Here this is incident ray, this is also incident ray. We are extending those incident rays, the light rays. Here it is meeting. Okay. So incident ray 1, incident ray 2. If you are extending those incident rays, so here virtual object, and here real image. Real image. The point of intersection of reflector light rays. So light rays, reflector light rays are directly meeting. This is RR1, RR2, reflector light rays are meeting directly. So here, that's why it's a real image. Real image, the point of intersection of reflector light rays. The point of intersection of reflector light rays is known as real image. The point of intersection of extended incident rays is called virtual object. The point of intersection of extended incident rays is called virtual object. The point of intersection of reflector light rays. 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 Point of intersection of reflector light rays is called real image. Point of intersection of extended incident rays. Point of intersection of extended incident rays is called virtual object. So here I am considering here by observing these two cases, case 1 and case 2, case 1 and case 2, case 1 and case 2, by observing these two cases we can conclude that, so object and image, object is real, image is virtual, object is virtual, image is real. So we have to conclude this one. Okay, so this is about real image and virtual image, real object and virtual object. So like this, real image, virtual image, real object, virtual object. Okay, so object types and image types. I hope it is very clear. Now we will go with that one more. So image, characters of the image formed by the plane mirror. Characters of the image formed by the plane mirror. Okay, so here I am considering characteristics of the image formed by the plane mirror. Okay, so I am taking the plane mirror. Object is placed. So I am taking the plane mirror like this. I am taking the plane mirror. So this plane mirror. This is a plane mirror I am considering. This is a plane mirror. One side is reflecting surface, another side is coated one. One side is reflecting surface, another side is coated one. So here I am considering this object. This object, height of the object is AB. Height of the object is AB. So height of the object. So this is AB. AB is the height of the object. One light I am taking like this, and one more light I am considering. So like this, it will be reflected back. Okay, so one light I am taking like this, and here. Okay, so it will be reflected back, and I am considering if you are extending this light rays, we are extending this light rays here, and here I am also considering. So virtual image will form. So virtual image will form. Here also virtual image only. This entire case. Virtual image. So A dash, B dash, AB is the object, A dash and B dash is the image. So here first point is height of the object is equal to height of the image. Height of the object is equal to height of the image. And the second point is object distance. What is the object distance? Distance between object to mirror. Distance between object to mirror is called object distance. Distance between mirror to image is called image distance. Distance between object to mirror is called object distance. Distance between mirror to image is called image distance. So object distance is equal to image distance. Object distance is equal to image distance. Object distance is equal to image distance. And we can also see the third point is lateral inversion. Lateral inversion. Lateral inversion. So it shows the lateral inversion. It shows lateral inversion. What is the lateral inversion? The phenomenon of converting of right side of the object appears to be left side of the object appears to be right side. So what is the lateral inversion? The phenomenon of converting of right side of the object appears to be left side of the object appears to be right side. Okay, so this phenomenon is called lateral inversion. This phenomenon is called lateral inversion. Once again, the phenomenon of converting of right side of the object appears to be left side of the object appears to be right side. So this phenomenon is called lateral inversion. So ambulance, you can see the ambulance, how the letters written on the ambulance, it will be in a mirror image. So if you see in the mirror, it appears rear view mirror in the cars, vehicles. Side view mirror, in the side view mirror if you see, so that ambulance letters will be appear proper. Okay, so that is called mirror image. So that is nothing but the converting of the phenomenon of converting of right side of the object appears to be left side of the object appears to be right side. This phenomenon is called lateral inversion. So lateral inversion. So this is about plane mirror. And next one will go with the spherical mirrors. Spherical mirrors. Spherical mirrors means nothing but, okay, so here spherical mirrors. Spherical mirror. Spherical mirrors I am considering. So if you are taking like this is a part of the sphere. So it is a part of the, so if you consider small portion, okay, small portion, just go through it. I will come, just 1 minute. Here, yes. So it is a small portion I am taking. This is the curvature. This is a small portion I am taking. This is the curvature. This is the curvature. Okay. So I am taking a small portion, right? That's called curvature. Okay. This is the curvature. Curvature I am taking. That is called mirror, spherical mirror, where reflecting takes place. So depends on, so the mirror which is in the form of curved shape, that is called spherical mirror. So depend on coating surface. Depend on coating surface. If you are taking this mirror, okay. So outside is coated, reflecting takes place inward. Outside is coated, reflecting takes place inward. This type of reflection, this type of mirror is called concave mirror. This type of mirror is called concave mirror. So here you can observe. So coated will be outside. Reflection takes place inward. Reflection takes place inward. This type of mirror is called, so this type of mirror is called concave mirror. So concave mirror is also called converging mirror. concave mirror is also called converging mirror. So why we are calling concave mirror is also concave mirror is a converging mirror? Why? Because if the light rays are inciding on it, so these are the light rays. These are the light rays I am taking. Light rays. Whenever the light rays are incident on it, so after reflection, those light rays will reflect back. Those light rays will reflect back and meet at one point. So after reflection, those light rays will reflect back and meet at one point. So on the principal axis. So light rays are moving towards the principal axis. So these are the reflected light rays, reflected ray. So after reflection, light rays are moving towards the principal axis. So that's why converging the mirror which is converging the light rays. So that's why it is called converging mirror. So this mirror is also called converging mirror. So which one more mirror is there? Diverging mirror. That is nothing but convex mirror. Convex mirror I am considering. So this is a convex mirror like this. Convex mirror I am considering. So whenever the light rays are incident on it, so here I am considering. So those will moving away from it. Okay, reflection takes place outward. The type of mirror is called convex mirror. Reflection takes place outward. The type of mirror is convex mirror. But whenever the light rays falls on it, so those light rays are moving away from it. Reflected light rays are moving away from it. That's why it is called diverging mirror. So diverging mirror. So this what is this mirror actually? Convex mirror. What is this mirror? Convex mirror. So after incidenting the light rays, it will be diverging. Those light rays are moving away from it. That's why it is called diverging mirror. Clear? Nice. So next one, we'll go with the terms related to spherical mirror. What are the terms we used in the spherical mirror? We will discuss now. Terms related to spherical mirror. So 1 minute. So what is it? Okay. Next one. Very good. So what is that? Which mirror we are discussing? Spherical mirror. Terms used in the spherical mirror. So now we can see terms related to spherical mirror. I am taking the concave mirror like this. What mirror it is? Concave mirror. I am considering like this. Okay, concave mirror. So I am taking principal axis. So this is a point. The midpoint of the mirror. Actually, it is a part of the sphere. This is a part of the sphere. So we are taking the small portion, that is called curvature. We are taking small portion, that is called curvature. Okay, so the midpoint of the mirror is called pole. So the center. So normally if you are taking sphere, center will be there, right? So center of the imaginary sphere in which mirror is a part. Because this is a reflecting surface, center of the imaginary sphere in which mirror is a part. So that is called reflection. Okay, done. So after reflection, all light rays will meet at one point. So I am taking here after reflection, all light rays will meet at one point. So that is called principal focus. Light rays will meet at one point on the principal axis. So that point is called principal focus. This point is called principal focus. So the distance between central curvature to pole. is called radius of curvature. The distance between center curvature to pole is called radius of curvature. The distance between center curvature to pole is called radius of curvature. The distance between center curvature to pole is called radius of curvature. And the distance between focus to pole, 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 the distance between focus to pole is called focal length. So this is the focal length. The distance between focus to pole is called focal length. The distance between center curvature to pole is called radius of curvature. And the width of the mirror, so this width of the mirror is called aperture. So I am taking this aperture. The width of the mirror is called aperture. Width of the mirror is called aperture. So those who are watching, please do like, share and subscribe my channel, and you can share to your friends also this video. So informative video, so related to CBSE grade 10 physics, light reflection and diffraction chapter. Very important topic, very important points I'm discussing. So please do like, share and subscribe my channel. Okay, if you like this content, you can share to your friends also. Here aperture. So once again all the points we'll discuss. One is pole, second one is radius of curvature, third one is principal focus, fourth one is focal length, fifth one principal axis, the line joining of center curvature and pole, the line joining of center curvature and pole, the line joining of center curvature and pole, the line joining of center curvature and pole is called principal axis, principal axis, and the sixth one principal focus completed, radius of curvature is completed, aperture, width of the mirror is called aperture, any other points? Center of curvature, center of curvature is missed. So these are the seven parts. Once again, pole, radius of curvature, principal focus, focal length, principal axis, aperture and center of curvature. These are the points. Okay. So any doubts? If you have any doubts, you can let me know. Still, if you have any doubts regarding the subject and content, please let me know. Okay, so this is about terms related to spherical mirror. Next one. Okay, so this is about terms related to spherical mirror. Now we will go with that ray rules. I'll explain ray rules. So I'm taking concave mirror. Okay, whatever we are taking concave mirror I'm explaining. So concave mirror, here I am considering concave mirror. Okay. So this is the point, pole, focus, center Curvature. Every time whenever you are drawing the diagram, every time whenever you are drawing the concave mirror, every time whenever you are drawing the concave mirror, you must place the points. What are those? Pole, focus, center curvature. Pole, focus, center curvature. Okay. So one light I am taking like this. After reflection, it passes through the focus. So one light I am taking, after reflection, it passes through the focus. Another light I am taking like this. So this is a ray rule 1, and ray rule 2, So here I am taking one more. So this is a pole, focus, center curvature, pole, focus, center curvature. So one light I am taking like this. It passes through the focus, after reflection passes towards infinity. So ray 1, after light is coming from infinity, after reflection passes through the focus. Second ray, so light ray passing through the focus after reflection passes towards infinity. And third one I am considering. So here, so pole, focus, center of curvature, light ray is passing. So light ray is passing through center of curvature here. Light ray is passing through center of curvature. So after reflection, so it retraces its original path. If it is passing through center of curvature, it moves in the same direction. And we can consider, so fourth one, we can consider here. So we need to understand this four ray rules. Ray 1, after light ray is coming from infinity, after reflection passes through the focus. So light ray passes through the focus, after reflection moves towards infinity. Light ray is passing through the center curvature. Okay, so next, last one. Last point is very, very important. Last point is very, very important. So here I am taking, here is the pole, focus, center curvature. If the light ray incident at the pole, so it will reflect back into the, so it reflect back into the same. Okay, so here I am considering light rays incidenting at the pole, it will reflect back, okay, into the same medium. One light ray I am taking, so one light ray I am taking, after reflection passes through the focus. So another light ray passes through the focus. So another light ray passes through the focus. So after reflection passes towards infinity. So one more light ray passing through center curvature, it retraces its original path. So I am taking one light ray incidenting at the pole, it reflects back into the same medium. Here, these are the four ray rules. So when you are going to war, you need weapons. Yes or no? So for drawing the image formations, we need ray rules. These are the ray rules, four ray rules. Okay, these four ray rules are used to draw the image formation. See here, we no need to use all these four ray rules at a time. We need a minimum two ray rules. Minimum two ray rules required to form the image of the object. So minimum two light rays we can take. So among these four ray rules, we need only two ray rules. You have to select, you have to choose. So in the exam they will ask, choose, so object is placed between somewhere, so image will form. What are the ray rules you choose and explain it. Okay, so we have to explain. So how we have to explain? So if you are taking this two, I will explain when you are taking the image formation. Now I am telling about it. So object is, light ray is coming from infinity, after reflection passes through the focus. So light ray is passing through the focus, after reflection passes towards infinity. And I am considering if light ray is passing through center curvature, it retraces original path. So like that you have to explain. All these ray rules. Now we will go with the image formations. So image formations. So what are the image formations? Image formations by spherical concave mirror. Now I am taking the concave mirror. So here point number 1. So I am taking the concave mirror like this. Okay, so concave mirror I am considering. So this is a pole. Focus, center curvature. Every time you are mentioning the points, you have to understand the definition also. Pole, midpoint of the mirror. So after reflection, all light rays will meet at one point on the principal axis, that is called focus. So the center of the imaginary sphere in which mirror is a part. center of the imaginary sphere in which mirror is a part. So that is called center of curvature. I am considering the center of curvature. Center of curvature. Okay. So next one, we are going with the image formations. Next one, so we'll take when the object is placed. When the object is placed at infinity. Object is at infinity. Okay. How many light rays are required to form the image of the object? Minimum 2 light rays. So I'm taking one light ray here like this. So and one more light ray. After reflection, those light rays will meet at one point on the principal axis. So principal focus. Okay. Object at infinity. Image is formed at focus. Image is formed at focus. What is the nature of the image? Real inverted. Nature is real inverted and highly diminished. 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 That is the nature of the image. So highly diminished is nothing but size of the image. Real inverted is nothing but nature. Real inverted is nothing but nature. Highly diminished is the size. Highly diminished is the size. And okay, so this is about object is at infinity, image is formed at focus. So nature is real inverted and size of the image is highly diminished. Size of the image is highly diminished. Okay, so next one, object is placed beyond center of curvature. Object is placed beyond center of curvature. Here I am considering like this. So here, so here I am taking like this. So pole here. This is a pole, focus, center of curvature. Pole, focus, and center of curvature. One light ray I am taking. Object is placed beyond center of curvature. Object is placed beyond center of curvature. Here I am taking object is placed beyond center of curvature. One light ray I am taking here. So one light ray I am considering like this. So how many light rays are required to form the image of the object? Minimum 2 light rays are required. So one light ray I am taking like this. It passes through the focus. And one more light ray I am taking like this, passes through center curvature. Yes. So where image will form? Between C and F. Between C and F. Object beyond center curvature. Object beyond center curvature. Beyond C. Where image will form? Between C and F. Between C and F. What is the nature of the image? Nature of the image is real inverted. Real and inverted. Okay. Real and inverted and diminished. Real inverted and diminished. Here image is formed real, inverted and diminished. And okay, so this is one direction. This is one direction. This is one direction. Directions are very important. I hope it is very clear now. So next one, next image formations. Object is placed at center curvature. Object is placed at center curvature. I am taking this object. Object is placed at center curvature. Here I am taking this object. So here pole, focus, center curvature. Object is placed at center curvature. Here I am taking. Here I am considering. So one light ray I am taking like this. One light ray I am taking like this. After reflection it passes through the focus. So another light ray. So we can take at the pole. We can consider at the pole. So here okay, so here I'm considering this is the central curvature, this is the center of curvature. So one lighter I am taking, another lighter I am considering like this. So it will meet here. Okay. So this is the object height, this is the image. Object is at center of curvature. Image also formed at center of curvature. Object is at center of curvature. Image also center of curvature. Nature. What is the nature? Nature is real, inverted. Nature is real, inverted, and same size. Same size. Same size of image will form at center of curvature. Same size of image will form at center of curvature. Clear? So next one, we'll go with the one more. Object is placed. Object is placed. So I'm taking so here it is the pole. Focus. Center of curvature. So I'm taking object between C and F. Between C and F. One lighter I am taking like this. So it passes through focus. So another lighter it is incident at the pole. So it will be reflect back. Then image will form here. Okay. So here I am considering so one lighter I am taking like this. So here object is between C and F. Object is between C and F. Image will form. Image will form. So image will form. Where image will form? Where image will form? Anyone can answer the question, please. So I'm continuously saying, at least from your end, if you know the answer, so please do comment. So I'll feel very happy. So at least it's like a boosting to me. So I'm saying, so those who are there in the live class, those who are listening, if you know the answer, please try to answer. So you can involve in the class. So you can let me know. So if you know the answer, you can let me know. It's fine. Okay. Object between C and F, image will form. Image will form beyond center curvature. Image will form beyond C. Nature of the image is real, inverted, and nature is real, inverted itself, and size means enlarged. Compared to the object, image size is increased. Compared to object, image size is increased. Compared to object, image size is increased. So here once again, object is placed between C and F. Image is formed beyond center curvature. So what is the nature of the image? Real, inverted, and the size of the image is enlarged. Size of the image is enlarged. Okay, so that's enough. Size of the image is enlarged. That's enough. Next one, we'll go with the object is placed at F. Object is placed at F. Object is placed at F. So we can see you are placing the object at F. So pole, focus, center of curvature, pole, focus, and center of curvature. Center of curvature. One lighter I am taking like this. One lighter I am taking. So here at focus we are placed. So I place the object at focus. Here I am placing. One lighter I am taking like this. So it passes through the focus. Another light ray we can take through center of curvature like this. So parallel lines, this become parallel lines. Object at F, image is formed at infinity. Nature of the image is real, inverted, and size of the image is highly enlarged. Highly enlarged. Okay, so that is about object. And next one, we will go with the one more last case, very important case. So very important. So we'll see now. Very important case. The last case is object is placed. Object is placed. So pole, focus, center of curvature, pole, focus and center of curvature. Object is placed here. Object is placed here. One light I am taking here. One light I am considering. One light I am considering. So it will be reflected back. It passes through the focus. Another light ray passes through the center of curvature. Passes through center of curvature. So if you are extending these light rays, we are extending this light rays, the image will form behind the mirror. So here is the image will form. Object is between F and P. Object between F and P. Image is behind the mirror. Behind the mirror. So position of the image is behind the mirror. Nature is virtual erect. Virtual erect nature. Nature is virtual erect. Virtual erect and nature. Nature is virtual erect and the size of the image is so enlarged. Compared to the object, image size is increased. So this is about image formations of concave mirror. Image formations of concave mirror. Okay. Next one we'll go with the convex mirror. So where we'll use convex mirror? Convex mirror is used in solar furnaces to convert the light rays. Solar furnaces. So convex. So convex mirror used in solar furnaces, and dentist also to observe the teeth. Okay, palm is dentist. So these are the uses. Next one we'll go with the one more. What is that? Convex mirror. Convex mirror. Shaving mirror also. Convex mirror. So we are working with the convex mirror. What is the convex mirror? Convex mirror is nothing but, so only two cases in convex mirror. It is also known as converging mirror. In convex mirror only two cases are there. One is, so object is at infinity. Object is at infinity. So pole, focus, center of curvature. Object is at infinity. One light I am taking like this. Okay, so convex mirror. So object is, so if you are taking object is at infinity, infinity means parallel lines, parallel lines, parallel lines, parallel lines, parallel lines. So I am taking the parallel lines. So after that it will be converging and okay, if you are extending this reflector light rays, those are meeting at focus. So object is at infinity, image will form at focus. Nature of the image is virtual, erect and diminished. Highly diminished because point size image will form at focus. The next one more. So virtual images. So we can see next one more case is there. That case is, so object is placed between infinity and object. So I'm taking this one. Pole, focus, center curvature. Object is placed in front of the mirror. One light I am taking like this, it will be reflecting back. Another light I am taking, it will be incidenting, it will be reflecting. So if you are extending this one, image will form here. So object is between object between F and P, object between P and infinity. So pole and infinity. Nature of the image is virtual, erect, and diminished. Size of the image is diminished. So this is about image formations of concave and convex mirror. So if you like this content, do like, share, and subscribe my channel. If you like this content, do like, share, and subscribe to my channel, Student the Brand. Okay, so and I am providing a course. If you like this content, do like, share, and subscribe to Student the Brand. I am providing the course. So CBSE Grade 10 Physics, CBSE Grade 10 Physics. Okay, 4 chapters. Soft copy notes also I will be providing. Soft copy notes, 100 definitions from 4 chapters, 100 problems from electricity chapter. So this everything I am providing with the cost of 500 rupees. Okay, so with the cost of 500 rupees, those who are interested to take the course, you can call to this number. I am giving the number, so you can see the cost of 500 rupees. So I am providing the course. So 9849812804. So you can contact to this number. WhatsApp is there. So this is about Shiva sir. If you like this content, do like, share, and subscribe to Student the Brand. Thank you.